here with us tonight. So I'd like to introduce our speaker for the evening, Dr. Barry Levin. Just a bit about Barry. During his early training as a resident in internal medicine at Cornell-affiliated hospitals, Dr. Levin worked at Rockefeller University with Dr. Jules Hirsch, one of the founding fathers of obesity research, to assess various metabolic, physiological, and psychological aspects of extreme caloric restriction as a treatment for the morbidly obese. He then went on to train in neurology at Cornell and NIH, and then to pursue a career in academic neurology at Dartmouth and New Jersey Medical School. His initial research interest in neuroplasticity was supplanted by a long research career in the basic mechanisms underlying the ways in which the brain monitors and regulates physiological and metabolic status of the body and in animal models of obesity and type 2 diabetes. So thank you, Barry. Take it away.
Thank you all for coming tonight. If it's all right with you, I'm just going to sit. It's a small group, and I'd like to keep it really casual. And please, if you have a question, raise your hand. I'd like to keep it as interactive as possible. You might have gathered that my career in research has been predominantly with animals, rats mostly. I do not do work in human obesity, although I know a reasonable amount about it. But I'm going to be talking mostly about human obesity because it's most of what you're going to want to hear about. I'm a neuroscientist, so I'm going to have a little insert there to talk about how it regulates the way we eat and spend energy and so forth. And that may be the toughest part for some of you to get through, but please stop me at any point. Okay? All right. So I will sit. So the first thing I like to do when I talk about obesity is sort of get some of these concepts that people have out in the open. And you can think about how you would answer some of these questions that I'm going to put up, or some of these statements. A common misconception among a lot of people, until more recently when we've been able to actually convince that obesity really is a disease, or at least associated with disease, that obesity is mostly a cosmetic problem. It's just not good to be fat. In our society, it's a terrible thing to be fat. Obese people become obese, and here are some of the possible things that people have said. And this is a common, even today, people say that they are obese because they lack willpower. They have a low metabolic rate. These two things are not true. They're lazy, not true. They're addicted to food. We'll deal with that briefly, and we can. Some of you may want to talk more about that. I'm not a believer in food addiction, but some of you may have opinions about that. And maybe they have obese genes, and I'll show you that it's probably true that there are genes, or at least a part of the obese population is obese because it has a set of genes that predispose them to obesity. And because they're raised in an obesogenic environment, which I will try to convince you is a very important part of why people become obese. And then many of you have heard of, and some of you may have tried these various diets that books have been written about or you see on television. And you may think they work, and I'll show you some data on that. So I don't usually like to joke a lot about obesity, but I think most of you know that we have an epidemic of obesity in the United States, in the world, even the underdeveloped world where famines are common, has a rising rate of obesity. And this is part of the reason why we have an increased rate of obesity. Many of you may, or some of you may be familiar with this concept of the body mass index, which is a calculated value of body weight in kilograms divided by your height in meters squared. You can go on Google. This is one of the sites, NIH sites, that can do a BMI calculator. It's not the best way to figure out who's obese, because all it does is take weight and height. And that's not a good measure of how much fat you have, which is what obesity really is about. But it's what we use as a standard because in much of human research, this has been a sort of gold standard which we measure. And normal would be anywhere from 18.5 to 24.9, and then overweight is this sort of in-between place where some of the things I'm going to say about obesity may or may not be true. Being overweight may not be a bad thing. Once you get up over BMI of 30, you're obese, and then you're morbidly obese if you're 40. I apologize to the women in the audience. I just had, for a 5'9" male, you can see how much variation in weight there could be for that height to be within one of these categories. So, the CDC has kept over the years this behavioral risk factor surveillance system, starting back in 1985. And what this is going to scroll through, and what you're going to be seeing is a change in the colors. And look down here at the bar, and you'll see this is the percentage of people in any given year who are obese by the BMI of over 30, all right? I don't know if all of you can see that. And watch this as it goes along. And you can see the darker colors, we're up to 10 to 14%. Now the dark is 15 to 20%, 19%. And now we're 1998, we're getting up over 20%. Mississippi and Alabama, over 25%. Now, in 2013, the last of the data that I could find, we have Mississippi wins along with, I guess that's Ohio, I should know this.
West Virginia.
West Virginia, sorry. I'm a neuroscientist.
And a New Yorker, obviously.
I never, oh, I have been to West Virginia. Anyway, but over 35%. The general figures are in the United States, 67 to 70% of the population is either overweight or obese, and about an average of 33% are obese. So it's bad. And all you have to do is walk down the street and you can see that. And it used to be when you went to Europe, you would see the striking difference. It's not so different there anymore. They're suffering from a lot of obesity as well. The other thing that's very important is as you go up over the years with increasing obesity in the top, down here is type 2 diabetes. And there's a direct parallel between the increases in obesity and type 2 diabetes. We used to call type 2 diabetes adult onset. We now see it in kids as young as 2 and 4 years of age. We've never seen that before. A really disturbing trend. These kids are obese. And these are probably the most important comorbidities, the things that are associated with obesity. So obesity per se is not really a disease. It's the things that it's associated with it that we worry about. So type 2 diabetes is top of my list. Hypertension is another one. Disorders of blood liquids, heart disease, clotting disorders, restrictive lung disease, degenerative arthritis, gallbladder disease, and several types of cancer are all in higher incidence in people who are obese. And there's an increase in mortality associated with obesity. And this is a real problem. And you can see that individuals have a 50 to 100% increase in risk of all causes. And for white men, you have a 2 to 13% increase, and black men up to 20 years, years that you lose for being obese. So this is a serious problem, and it's getting worse. This is the worst part of it. I don't know if you can see the line in there, but it says, remember when we used to have to fat the kids up first. And it's not funny, actually, because this is what's happening. We're seeing obesity in kids at an alarmingly increasing rate. You can see these are the different age groups. This only goes up to, I think, 2000, I don't remember, 2008. And even in kids 2 to 5 years of age, there's an alarmingly high rate of obesity. The good news is that this increase appears to be plateauing among kids of these ages. The bad news is that it's way too high. And if you're an obese kid, your chances of being obese and getting what we call metabolic syndrome, which is type 2 diabetes and hypertension and dyslipidemia. People will throw in other things, but that's called metabolic syndrome. Your chances of getting that are enormously increased when you're obese as a child. This is the way our genes were designed, if you want to talk about design or creationism. We were hunter-gatherers, and I actually visited one of these tribes in Tanzania, and this is pretty much what they look like. Low availability of food, and you had to work really hard to get that food. And so this is a population of people who are always lean. And there's a premium, once you get that food and ingest it, on holding on to that food. Unfortunately, this is our lifestyle now, sedentary, waiting for us to lose our legs and just have big thumbs and to work our smartphones. And there's this question of thrifty genes. This is a concept that's very controversial in the field. The idea is that we evolve these genes, as I said, that help us hold on to the food, first of all, to seek food and be able to ingest it when it's available, and then to hold on to that food, those calories, once the food is not available. Again, there are arguments pro and con. I have to believe that at least some of the population has this. This is a bit out of date. Most studies would say that up to 70–75% of obesity has a genetic basis, and that's very loosely speaking. There are very few disorders in which obesity is due to a single gene mutation. The most common one is due to, well, it's a receptor defect. But that makes up less than 5% of all cases of obesity. The rest of the cases of obesity that can be attributed to a genetic background are polygenic. This is what most of our common chronic diseases are. Things like type 2 diabetes, hypertension, a number of other diseases. We don't know what those genes are. We have some associations, and there are several genes that have been identified from very large, thousands and thousands of subjects that have a higher association with obesity, but not one of them alone causes obesity if it's mutated. And this is really, to me, the most important part of this, because it's probably the only thing we can do about obesity, and that is the fact that you take this genetic background that many of us, up to 75% of us, may have, and then you superimpose on that conditions during the gestational and perinatal period, postnatal period, many of which can be obesogenic, and we'll go into some of those. And these can have profound effects on the development of organs, the brain, as Woody Allen used to say, my second favorite organ, and the pancreas, stomach, and fat tissue. And these can be modified, so your genes can be modified by these epigenetic mechanisms, that is, things that act on the genes after they've already been expressed. And these together lead to obesity, usually in adulthood. So it increases the genetic predisposition. And so this is the time we want to pay particular attention to. Morton Downey, a number of years ago, 3 years ago, made up this list of putative, I don't even know that you can see it, it's not important. There are 82 here, I could probably add to them. You might want to pick out one of your favorites or several of your favorites. Most of these are associations. Virtually none of them have been causally proven to be. Machines? What's that?
Vending machines?
Oh, sure. Yeah, because it's easy access to food. You just put your money in, and out comes a 4,000 calorie candy bar. So sure. But this is why we get fat. It's really not magic. If we eat more than we expend in energy, then we increase the storage of calories, and virtually all of that is in the form of fat. And the fat at first goes into our adipose stores, but then it ends up in our muscles and particularly our liver. And when that happens, that contributes to type 2 diabetes, because fatty livers and fatty muscle are insulin resistant. And so there's this vicious cycle. So it you can't get fat unless you eat more calories than you expend. It just isn't magic. And there are people now who say, David Ludwig likes to say that, well, if you eat the wrong kind of macronutrient, carbohydrates or sugars, and there's a cogent argument to be made for that, but the facts really don't support it. And I'm of the opinion that it's a calorie in, calorie out situation. And these are some of the things that we all know contribute to obesity. All of these fast foods, sedentary lifestyle, and even our pets are getting fat. The rate of obesity and type 2 diabetes in cats and dogs is going up enormously in our population. At least this one is getting some exercise. This varies by region in the United States and by ethnic group, but typically they're about 35 to 40-something% of our diet is fat. And again, there's this argument about whether it's high fat is now fat is good. All of a sudden it's become good. I don't think a high-fat diet is good for anybody. But also simple sugars, the thing about this is they can be readily digested and absorbed, so it doesn't cost a lot to get them into the system and to put them into energy storage. And if we just look at sort of the leanest males and females, or lightest weight, you see some estimates of your daily caloric needs if you're sedentary versus you do moderate or heavy exercise, or your work includes increased outlay. And you can see that for a sedentary man, a typical 70-kilogram man, less than 2,000 calories a day. And I would say it's probably less than that. And for females, it's less than 1,500. If you do exercise or increase your energy expenditure, you can significantly increase that. And so increasing energy expenditure is one way to prevent getting obese. Unfortunately, it may not be the best way to help lose weight. And this is occupational outlay of calories. And it seems like it's pretty modest in what's happened in the decrease from 1960 to 2010, only 140 kilocalories a day for men and 120 for females. That's about 14 potato chips for men and 12 potato chips for females. But you have to run almost 1.5 miles if you're a man and 1.2 miles a day to get rid of that number of excess calories. And if you don't, and you continue eating at the higher rate, you're going to continue to put on weight. So it seems small, but this is per day, right? And it's going to add up quite a bit. So my interest is in how the brain knows what's going on in the body and the environment. How do these communicate with each other? And so the periphery has a number of ways that it can send signals. So this periphery being the body, but also the external environment. So we have neural inputs from the gut, from the primary senses of sight and smell and taste, which promote ingestion. There are hormonal and metabolic cues, substances that are produced in the body, which can cross into the brain. The brain is relatively protected. It has a blood-brain barrier. Most of these things are easily transported into the brain, and they act as signals. And then there are psychosocial factors that we're all exposed to. Most of us in my area study rats and mice. There are not so many social pressures in rats and mice, but there are in humans, and so sometimes we can't factor that in. The brain is important because it can integrate all of these signals that come in, and it can then undergo a certain amount of plasticity. It can change its wiring, form new circuits. This is all somewhat limited, and it can go back and forth, but some of these changes appear, once they appear, can become near permanent. With obesity, it seems to be that something happens as you get obese that forms a near permanent set of circuits that prevent you from becoming unobese. And then these signals are integrated, and then there's an output for food intake and neuroendocrine responses and absorption, assimilation, calories that you eat, heat production, energy expenditure, exercise, and storage. And then peripheral organs can also undergo a certain amount of integration of these signals and plasticity. The important thing is there's a constant discussion going on, dialogue going on between the periphery and the brain. One can't function without the other. They're both integrally related, and the brain is totally dependent on the information coming in from the periphery. Otherwise, it can't really do anything. So much of my work and the early work in the field of how the brain controls what we call energy homeostasis or balance centered on the hypothalamus. We now know that this hypothalamo-centric view of the brain is very naive. There are places all over the brain that are involved in phases of energy homeostasis, intake, expenditure, and storage of calories. And they form a dispersed or integrated network, and they function as a network. You can make a hole in one place or the other and disrupt that system, and that was sort of how we focused on the hypothalamus. So I'm going to give you sort of a very simplified view of actually where we started in the neurochemistry of the hypothalamus, about two neural systems that control body weight to some degree. There's this little nucleus called the arcuate nucleus right at the base of the hypothalamus. Here's the pituitary gland here. This is the base of the brain. It contains neurons that are mostly sensory neurons. They get information from the periphery and from other areas in the brain. And then there's an area called the paraventricular nucleus, which is just upstream of it, which is mostly an output system. It's responsible for most of the neuroendocrine and behavioral and other effects. And again, I'm simplifying this, but within the arcuate nucleus, there are a group of neurons, nerve cells, that make a peptide. I don't know if you all know, a peptide is a bunch of amino acids, usually under 40 of them, small protein-like molecules. And neuropeptide Y is in many places throughout the brain and the body, but in these particular neurons, neuropeptide Y, when these neurons that project to the paraventricular nucleus, when NPY is released onto the neurons in the paraventricular nucleus, the animal has a basically unquenchable desire to go seek out food and ingest food. And at the same time, there's a mild decrease in energy expenditure. So we call this an anabolic peptide. Anabolic meaning that we're putting, it drives the animal to put on more energy. Sitting right next to those and interspersed, depending on the species, there are other neurons that make a much longer peptide called pro-opiomelanocortin or POMC. It's not important what it is. That is cleaved into a number of different smaller peptides, one of them being alpha melanocyte stimulating hormone. When this is released on the terminals from these arcuate neurons into the paraventricular nucleus, oh, what happened? I lost, well, somewhere I lost it. Oh, there it is, I'm sorry. So when you release alpha MSH or POMC, what happens is you get a decrease in food intake and an increase in energy expenditure, a fairly marked increase in energy expenditure, and this is catabolic. Right? So you have this balancing act between these two, and when one is activated, the other is always inactivated, and these are all relative. Now, probably the most important thing that's happened in the last 20-something years is the discovery. Since the 60s, there's always been this hypothesis that fat tissue, adipose tissue, made some compound that told the brain how much fat tissue there was in the body. But nobody could find that. And then in 1994, Jeff Friedman's laboratory at Rockefeller discovered that that substance was something called, that he named leptin, which means thin. It's a Greek word, leptos, means thin. And leptin is made in proportion to the amount of adipose tissue that you have. So the obese people have bushel baskets full of leptin circulating in their blood, whereas thin people, the best example are these young prepubescent acrobats, not acrobats, what do you call them? Gymnasts. And they have no fat tissue, and they have virtually no leptin. And although it's a side issue, you can't develop secondary sexual characteristics or reproduce if you don't have any leptin. And so these little girls, most of them are girls, essentially never have menses, or if they have them, they're irregular, they don't develop secondary sexual characteristics. But for our purposes, the reason we've been interested in leptin is that it's a negative feedback system to the brain. So when leptin is made by adipose tissue, it circulates in the blood, it goes across the blood-brain barrier, and it interacts with many areas in the brain, but in this case we'll talk just about these neurons in the arcuate nucleus. And it's a negative impact on NPY. So because when you get fatter, you make more leptin, you don't want to eat more, so it inhibits the anabolic, and it stimulates the catabolic pathway, right? So this is the part that may be a little bit, so is everybody following that? Because if you don't feel embarrassed about asking questions. Okay, all right, so it's a negative feedback system. The problem is that once you have too much leptin, you'd say, well, if obese people have all this adipose and they have all this leptin, why are they still eating too much? And the answer is that the brain stops paying attention to the leptin. You get leptin resistance. There are a lot of reasons for that, and some people question whether that's really true. But less of it gets into the brain, and when it gets into the brain, there are fewer receptors and downstream signaling. The brain just stops paying attention to it. So you can have as much as you want, but it really doesn't effectively keep you from eating too much. And this was, these were the original mice that Friedman's group worked on. These mice have been around since the 60s. And that one on the right has no leptin. And that's where the discovery came from. Friedman looked at the mice that were lean and the ones that were littermates that were fat, and discovered that it was this substance leptin that they don't have. So if they have no leptin, there's no inhibition of these anabolic pathways. And these mice eat voraciously, and their energy expenditure is very low. And in fact, so you have, if you looked at their brain, in the arcuate, you'd see an increase in neuropeptide Y and a decrease in POMC. So increase in the anabolic, decrease in the catabolic. So they have this massive increase in food intake and a big decrease in energy expenditure. There are very few, but some humans first discovered by Faruqi at Cambridge in England. These families of individuals who have no leptin. They make up a tiny percentage of the overall obese population, but when you see them, the way they identify them is they took massively obese kids, and you can see this kid was very obese. But when he was treated with leptin for 2 years, he lost a fair amount of weight and stopped being hungry all the time. So you can replace leptin in these individuals, it's just that there are very few of them. Now, I've told you about these two systems, NPY and POMC, but this is a small overview of all the other peptides and neurotransmitters that we know about that are produced in the periphery, in the brain, in different areas of the brain, and this is a fraction of what we know. And every week there's a new peptide or transmitter being identified. The important thing is that I've tried to give you a little snapshot of a very simple system, but you can see this is an extremely difficult system. And the problem is if you work on just those two and you can manipulate them and change them, you've got all these other ones that can compensate. The main thing that the brain tries to do is keep the body from starving to death. And so when you don't have much leptin around, when you don't have much adipose tissue, it's actually the absence of leptin that's the most important thing, because when you don't have leptin, you stimulate that anabolic system, and that's what makes you starve or feel like you're starving when you've been fasting or in a situation where there's little food around. Unfortunately, the same thing happens when you're a 300-pound person and you've gone on a diet. So one of the things I always like to think about is what is it that gets us to eat our next meal? Why do we bother? So maybe you eat dinner at 6 o'clock, you wake up, I wake up at 5, some of you may a little later, so you've been fasting for 12 hours. So maybe you have a little depletion in your energy stores. If you weigh 300 pounds, you haven't had much of a depletion in your energy stores. But you could argue that that's why you eat breakfast. But why do you eat lunch? You think in 4 or 5 hours that you've lost enough energy that that's going to stimulate you to eat another meal or dinner? And the answer is really not. That's not a very good reason why you would eat your next meal. How many of you think you get hypoglycemic during the day and that makes you hungry? Have you ever taken your blood sugar?
No.
You are not hypoglycemic. It's very common, and I'm not making fun of you, but people get the symptoms that they know or associate, unless you're diabetic or on some kind of medication, your insulin. A lot of people will tell you that they get hypoglycemia. It's extremely, extremely rare in nature for anyone to become hypoglycemic. When you fast, your blood sugar goes down, but it's replaced by fatty acids and ketones and so forth. But it's rare during the day to get hypoglycemia. There are body rhythms, circadian rhythms, which are daily rhythms in a lot of these metabolic substances we'll talk about, and hormones that can drive that. And so that may be part of it. The gut makes a number of peptides that respond to food in the gut, which then either directly or indirectly through neural pathways terminate a meal. So you think that's a little strange. Why would you want to do that? Well, if you didn't terminate a meal, you would do nothing but eat all the time. You wouldn't have time to do all the other things you need to do during the day. And so there are these satiety or fullness signals, and they, after food moves through the gut, then these go away. And so that not having those may be one factor. But I'm of the mind that it's mostly habit and psychosocial factors that get us to eat our meals. We are used to eating 3 meals a day. Not everybody does this, and we're in a situation where most everybody else is eating 3 meals a day, so we do that. But physiologically, I think there's not good evidence that we need to do that. And then there's this issue of food addiction. How many people think that there's food addiction, or that they're addicted to food? Okay. Okay, that's fine.
Actually, you know what?
Yeah.
A question I have.
Yeah, sure.
So far as you've presented this really compelling story about, chemicals in the brain that create a brain response that either cause you to eat a lot and cause you to eat a lot voraciously, or don't cause you to eat. Right. And then you also said that the changes that occur are very hard to reverse. How is that a differing mechanism from addiction?
We can talk about that in a little more depth later on. Addiction usually is thought about as being in this part of the brain. So these are human, these are PET images, positron emission tomography. It's not important what they are, but these areas in the brain are areas that have receptors for dopamine. And I think there's enough in the press about dopamine being the reward factor. It's released into this area called the striatum in situations where there's reward. And that could be alcohol or heroin or food. But almost always with food, it's a novel substance. So dopamine is, when you are exposed to a new food, for the first few times you get dopamine released into this area, and then it stops being released. But what Nora Volkow, who's head of the National Institute of Drug Addiction, and Roy Weiss, who's worked there for a number of years, did, looked at humans who are either controls, and red is a lot of receptors for dopamine, and here you can see little or none, or very few, in addicted people for alcohol and heroin, very similar picture. So these receptors are in low abundance, so it takes more dopamine, more of the rewarding substance to get the same bang for your buck when it's released. At least that's the theory. Right? So you have a decrease in these receptors, and so you need more of the addictive substance to release more dopamine. They then went on to look at obese subjects. Now, we can talk about this at the end, but there are a number of problems with this. But obese subjects have fewer of these same receptors. Now, the question is, what is it? Why would they have less dopamine in their brain? We don't even know that they have less dopamine in their brain. What is it that they lack in terms of reward? They showed that the heavier you are, there's a BMI of 60, these are massively obese people, the fewer these receptors you have, particularly in obese people. So they would say that this is because it's the same area of the brain, that this is related to addiction. There are data in animals and humans that are somewhat supportive of this. Behaviorally, there's probably one group of people, these binge eaters, who have this, essentially, this desire to eat that they can't control, and they eat huge amounts. Many of them also are bulimic, so they throw up what they eat and can maintain their weight this way. But other than that, most obese people are in weight maintenance, and they're not eating too many calories. They're eating enough calories to maintain their body weight. Many of them will slowly gain weight, as most of the people as they age gain more weight. So you eat as few extra potato chips a day and don't expend extra energy, so you do tend to gain more weight. But most of these people are not overeating who are weight stable, and many of them are not overeating on a daily basis. Right? So it's hard to say that addiction is food addiction. And don't forget, these are not substances we need to live, but we can't do without food. So teleologically, it doesn't make much sense to me. But that's not a good argument for anything in science. So then the question is, why is it we get hungry when we've been fasting, or when we diet and reduce our caloric intake below what our needs are? And there are a lot of answers to that, but I'm just going to show you some work that we did, and this has been done by a lot of other people. So this is that bottom of the brain, the arcuate nucleus, and this black here is a marker for the expression of NPY gene, right? So this is how much NPY gene expression there is. It's not quite that simple, but that's in a freely feeding rat, right? Obviously the rat is not feeding anymore since we've got its brain. When you fast, or if you chronically restrict your calories, even before you start to lose much in the way of adipose tissue, remember, leptin is made in proportion to the amount of adipose tissue, and the one exception is when you calorically restrict yourself, either by fasting or by going on a diet and eating less than your daily needs. Leptin levels drop sometimes almost unmeasurable amounts, and there are a lot of reasons for that. It's not totally known why. So they drop out of proportion. And this is that idea that I was talking to you about, that leptin is most important to drive you to eat when there's, to let you know that you're hungry. Because leptin would normally inhibit neuropeptide Y. Remember, there's a negative feedback. But when it's not there, you get an increase in neuropeptide Y and the other anabolic peptides, and you get a decrease in the catabolic pathway. So essentially, what dieting and fasting is doing is increasing this anabolic drive. And here's the brain of an animal that's been fasted for 24 hours. And I don't need to quantitate that for you. You can see this huge increase in the expression of that gene NPY. And that animal, and if you can, under any circumstance, if you see a brain that looks like this, you know that animal's starving. And you know that if you put food in the cage, it's going to eat immediately. Okay? So there are other reasons, but that's one simple one. The biggest question for people who are obese is, why can't you lose weight? Well, again, let's go back to the hunter-gatherer. You know, there is a premium not only on being able to find food and catch it, but when you have it and you don't have food, like holding on to those calories so that you don't lose the calories. And this is some work that was done at Rockefeller University by Rudy Leibel and Jules Hirsch, who I worked with back in the 60s. He would bring in people, 300 to 500 pound people, and put them in the hospital for 6 months on low-calorie diets. In this case, they took people of different fat-free mass, which is mostly muscle. And so these are very small, thin people, and these often, these with a lot of fat-free mass also have a lot of fat. And this is their energy expenditure, their resting energy expenditure, when they're eating in energy balance. Then they pay them to either reduce their calories enough to lose 10% or 20% of body weight. That's a huge amount. And what happens is these white squares are where the baseline is, and when you lose weight, your body decreases its resting energy expenditure. All of its energy expenditure, you even get less active. And this is one of the most important way that it holds on to these calories. So when you diet, you're being opposed by this system that tries to hold on to all of these calories by reducing your energy expenditure. The resting energy expenditure is what you're doing right now by just sitting here in a chair, and even lower in sleep. Okay, so that's a big reason why it's so difficult to lose weight. And the more weight you lose, the more your resting energy expenditure goes down. So it's kind of a vicious cycle for dieting. It's great if you're trying to hold on to calories and you're lean. Not so good if you're obese. So how can you lose weight and keep it off?
Is that just for resting energy? Like when you exercise, is it and you're losing weight and you're eating less? I mean,
you're more efficient when you exercise when you've lost weight. So in other words, you don't expend as many calories. On the other hand, exercise happens to be, and we'll talk a little bit about this later, exercise happens to be one way to drive your resting energy expenditure up. It's just a little harder to do when you're calorically deficient. But yeah, you can drive it up with exercise.
But so with the same exercise, like someone who's eating less than they normally do would expend less energy than someone who's eating good.
Yeah. So this is a huge study that was initiated by Rita Wing and Jim Hill and a number of other investigators, and they are adding to this constantly, but this is an 8-year study. Nobody does these kind of studies. It's important for a lot of reasons. One is that they just took people and gave them the sort of educational material and occasional counseling that people who have diabetes get in terms of caloric need and diet. The other group had this intensive lifestyle modification. They would meet with counselors on a regular basis. They were put on exercise programs, everything you could think of. Their calories were monitored. And this takes a huge amount of resources. And you can see over the first year, they lost about 9% of their body weight. Okay? If you're 300 pounds, I mean, if you're 150 pounds, that's a lot of weight. But if you're 300 pounds, it may not be cosmetic, it may not be the worst thing about being obese. But if you're 300 pounds, you don't want to just lose 10% of your body weight. That's not a lot. On the other hand, it's sufficient to ameliorate a lot of these comorbidities. So your diabetes gets better, your hypertension gets better, your lipids get better. So medically, it's a really good thing. But the problem is that despite staying in the program, this is what happens. And by 2 to 3 years, you're back at a plateau. And so at best, there's an average of about 5% loss of body weight. That's still pretty good. That's enough to give you medical remission of some of these comorbidities. And these folks not gaining weight is actually a good thing in this group of people. So that's pretty good, but it's a pretty small difference despite all this effort. So that's the behavioral arm, and they're doing a little better now. They've been tweaking this system. This was a number of years ago. Well, no, it's 2014. That's the Look Ahead trial. So here are some of these diets you know. I don't know if you can even read those. So the top is the Atkins diet, and then there's the Zone, and that's Gene Ornish, and I've never heard of this one in here. And this is the number of individuals, and this is see if I can see it on the thing. This is about 20% body weight loss. And again, remember, I'm sorry, kilograms. So, what's that? Oh, you can focus on it. I needed a new prescription. Okay, so this is in kilograms, and for those of you who don't know, 1 kilogram is equal to 2.2 pounds, right? So roughly double. And so some of these people are losing a substantial amount of weight on these diets. But this is for 12 months. And remember what we just saw. Most of the people who are going to gain weight, regain their weight, do it within the first year to 2 years. So this is kind of skewing. These were not comparative studies, by the way. These are data taken and self-reported data, really. So take it with a grain of salt. But here's the top 10%. They did really well for the first 12 months. But as we get out into the other 90%, there's less and less weight loss over the 12 months, and some of these people, as would be expected, have regained. We don't know how many of them actually stayed on the diet. Again, it's all self-reported, and the worst thing or measure in obesity and food intake research are self-reported calorie intakes. People intentionally or unintentionally lie about it. So food diaries are not so good. These are different studies done, or a study done with different amounts of fat, protein, and carbohydrate in the diet. And you can see that high fat, low carbohydrate, or medium fat, high carbohydrate, you'll get about the same amount of weight loss over the first 6 months. It stays down for 12 months, and then you start to regain. And there are no statistical differences among those groups. So, and this is what we would expect if we carried that study on. So, at least for a study like this, and there are others that suggest, again, that low carbohydrate diet may do a little better, but it doesn't seem to matter in most studies.
Can you clarify something? So I'm
Sure.
a little confused. So, so you're saying that this is what they're reporting they're doing? So they're saying that they're on this diet for this?
No, this was a controlled study.
So this is a controlled study. So even though they're actually on this diet, throughout that whole period, they're gaining weight back, even though they're still eating the same as they ate in the beginning of the, from 0 to 6, they're eating the same.
They're eating the same diet,
right.
Self-reported.
Self-reported.
So it's almost no way to check on what you're eating. You can put radioactive, tracers in. It doesn't work well with large groups of people. And most of this regain is because people started eating more calories. They fall off their diets.
Okay.
But even on the same diet, there's evidence that after a while you start to regain. But we don't know.
Okay.
Again, a calorie in is a calorie out. So it's unlikely. And all of them, so, fat has 9 kilocalories per gram, whereas carbohydrate and protein is only 4 kilocalories per gram. So in terms of caloric density, if you eat one lump of fat and 1 lump of carbohydrate, you're getting 2 1/3 or 1/4 more calories in that fat for the same amount of mass. Okay? So those of you who stay up late at night and watch these infomercials may have seen some of these. This is pretty old, but you could have a ring, or you could have inserts in your shoes that magically make you lose weight, or you could, and this thing I think is still around, this fat burner, I think is still around. And these are the sort of snake oil treatments, but people spend millions of dollars on these. And the sort of joke, which is not funny in the obesity community, is that most obese people have lost hundreds of pounds over their life. The problem is, and you go on this, and there's a huge placebo effect, and you lose the weight, but then, of course, you regain. So, but the pharmaceutical industry has been into this hot and heavy, and in fact, I first got into the research in this field back in the 80s, collaborating with people at Roche who were trying to make drugs for obesity, and there's a real need for this, but there are huge problems with it. First of all, you have to have something that's going to cause a robust, and that's part of the problem, and a sustained weight reduction. And you'd like to combine this with some kind of weight loss program that gives dietary counseling. The biggest problem is not weight loss. Almost everybody can do that. It's weight maintenance. And you've seen that from the graphs that I've shown you. Weight regain is the real problem in obesity control. And something that would help you comply to a lower calorie diet, and something that will make you lose fat to the exclusion of lean body mass, which is basically your muscle. When you go on a diet and you lose weight, almost all of that is losing fat. But there's an inevitable amount of muscle mass that's lost when you lose fat. But fat is the storage depot that we deposit into and withdraw from when we change our caloric intake. It has to be sufficiently safe to justify chronic treatment, and chronic treatment really means lifetime treatment. This is an analogy to type 2 diabetes and to hypertension. You're not going to get better, or at least unless you do something as a lifetime. Now, I've told you that if you're obese and you lose weight, you may be able to get rid of your hypertension and type 2 diabetes. But for obesity, once people go off these drugs, if they've lost weight, they go right back up to work. And the big bugaboo is you have to have minimal side effects, and there can't be abuse potential. And the first drugs in the field were years ago when I was in medical school were the amphetamines, right? And that's what people were taking for weight loss. And obviously, what's that?
So it worked.
It worked, but the problem is that it didn't continue to work, and there were a few side effects. So there are currently 3 drugs in the U.S. These are the names of them. These I won't go into, but these are 2 of the 3 are combinations. This one is under re-review because of problems with efficacy and side effects. There are at least 2 more classes of compounds that are in the offing. Both of these sets of drugs, there's several of them, were initially designed for type 2 diabetes, and it turned out that there was some weight loss associated with it. And it's expected that some of these may be approved for obesity. But the problem is that almost none of them give you more than about 5% weight loss. Medically, that may be enough. And that's, so if we really believe that obesity has serious medical consequences, and we can alleviate that by dropping 5% of our body weight, then it's not a bad thing. But again, you're talking about chronic drug intake. And several of those drugs that are approved have serious CNS brain side effects.
So are all of those drugs targeting the same mechanism? Or?
No, they're all different.
They're all different. Right?
Sorry.
And yet none of them can get out of that 5 to 10% range.
Not so far. The best drug we ever had was a combination of fen-phen, and again, this is an average. There's some people who lose 15, 20%, and there's some people who lose nothing. And it's just in the last few years that the FDA has finally accepted the fact that there's some people who are going to be resistant to a single class of drugs or all drugs. It doesn't mean it's not a good drug because it may treat a third of the population. You don't want to exclude a drug that works in a third of people really well. And so they're starting to get a little more flexible about this. It's really important. And I've been associated with people in the pharmaceutical industry for a long time, and they're making their best effort at this, but it's a killer. The amount of money and time that's been put into it doesn't justify what they're going to make off this. Yeah.
You said that they each target a different mechanism. So did they ever do studies where they combine drugs? So that
well, that's actually what some of these are. This phentermine works on the sympathetic nervous system, and topiramate is an anti-epileptic drug. So I'm a neurologist, and I used to get calls when this topiramate first came out. I used to get calls from all my old residents who were in practice all over New Jersey and say, I put my patients on this drug and they're losing weight like crazy. You should know about this. And we still don't exactly understand how this works. We don't know the mechanism. So yeah, these 2 are combinations that work on 2 different, and it's something I've been pushing for many years because, as I said, I showed you all those different peptides and transmitters. They compensate for each other. So it's unlikely you're going to be able to chip away at one of those and not have the other ones compensate. And that's what is being attempted. The problem is that the amount of money it costs to do research on combination drugs, because the number of controls you have to do is huge. So they've resisted that until recently. This is a class of drugs that acts on only one system, but it doesn't work all that well. So again, 5 to 10% weight loss. They lose effectiveness, many of them, over time, and again, chronic treatment possibly for life. And many of them have unacceptable side effects. For example, topiramate, the anti-epileptic drug, puts most people to sleep. And so to get enough on to control seizures and or to cause weight loss is a real struggle for a lot of people. So you'll be thin, but sleep a lot. So, well, but you'll look really good. And the reasons that drugs fail are poor compliance and failure to change lifestyle along with it. You can't just do this on a drug. It's not going to work unless you change other things. And then the problem that I started out talking about is that the brain is able to undergo plasticity. These other systems just work around you. Look, the system was designed to keep you alive, keep you from dying from hunger. This was in the New Yorker this week, I thought it was appropriate. And, why do some of us get fat? Well, at least one of the reasons is our lifestyle and our sedentary lifestyle, and maybe a little too much Chinese food. I don't know what said that bad. So the question is exercise. We address that issue. Is that good? And what this says is, for those of you in the back, it says these are 2 hamsters and a running wheel. It says I usually do 2 hours of cardio, and then I do 4 more cardio, and then I do 2 more cardio. So the problem with exercise, 14 potato chips, 140 kilocalories, that's only a mile and a half of running, right? So that it takes a lot of energy expenditure. So a tablespoon of peanut butter, you have to run 2.5 miles to get off those calories. That's the real problem. Now, it does have a lasting effect, and there's some good things. It improves your cardiovascular function, it improves your lipid profile, lowers your blood pressure in general. And it does have a lasting effect beyond just the exercise. So it kind of, and the other thing that's not on here is it improves insulin resistance. So it helps people with type 2 diabetes. And overall, it will lower your mortality. But here's the problem. It says, be honest, how much are you exercising? There's a big blob of fat there. And that's the problem, is that people, it's really difficult. Some people love to exercise. The majority of overweight people, it's excruciatingly painful. And I've never watched The Biggest Loser, but it's painful. And when we do exercise, this is a slide that everybody in the field shows, but how could you have an exercise studio with an escalator? But, so not everybody takes it so seriously. So the big news in the field that's been around for a long time is this rewiring of the gut. The simplest and easiest to do with the lowest morbidity and mortality is a restrictive surgery. And it makes sense, right? You just make the stomach so small that you can't force enough food into it. Well, the fact of the matter is that it's only moderately, this is our governor, I'm from New Jersey, so our governor, Chris Christie, had this gastric banding procedure. You don't lose that much weight, and the regain is almost universal, often back to where you were. And if you've been, well, I would hope most of you wouldn't follow him, but I have to, because he's my governor. He's been regaining the weight that he lost. This is the most extreme, this Roux-en-Y, and it has a restrictive component, so the stomach is cut off. They bring up a part of the intestine that wouldn't see the food until way down, the jejunum. There's a lot of going on here. But you can imagine when you start to do this with the intestines, there are a lot of side effects of this. It's now done fairly regularly. Some people are so massively obese you can't literally get into them because they're so fat to do this procedure. And so you have to get them to lose a certain amount of weight because the morbidity of the procedure is very high. But this is a very effective procedure. People lose a lot of weight. Regain happens in a certain percentage of people, not everybody. The morbidity, if there are certain things we know about, there's a slight amount of malabsorption, and so you have to account for the vitamins and calcium and so forth. But it's a big deal. It's a big surgery, and it's not done lightly. But many people regain the weight when they do this. And it's expensive. So this is being done more and more. This is done much more than this because it's so simple, and there are variations on these kinds of surgeries that are being done. And it's reserved usually for people with a BMI over about 35 to 40. They'll call it morbidly obese. But that's not happening in most places. Surgeons can do this. Bariatric surgeons, the people who do this procedures, are making a lot of money these days, and so they do it. They'll do 3 and 4 or 5 of these a day. So let's get back to the initial question that we started out the talk. Why do some of us get fat? Well, I call this the sticky slope. So if you start out and you're lean when you're a teenager, and you go on a diet, let's say you're a teenage girl and you think you've got too much fat on your hips and you want to lose a little weight, so you go on a diet and you calorically restrict and you stay at that weight for a while. But as soon as you stop eating or stop restricting, you go exactly back to where you would have been. And in fact, what happens is you start to drift back up this slope. Your body weight and your body fat, more importantly, goes up and up and up. If you're obese, the same mechanisms kick in when you try to lose weight, even though you've got a huge amount of fat at this point. Your body still thinks, and your brain thinks you're starving. You don't have much leptin around, and it's still, even though you've got a huge excess of storage, your brain thinks it's starving, and it will defend that body weight. And so there's this constant drive of hunger. It's not because people don't have willpower, it's that all of their biology is telling them that they're starving. And resisting that is almost impossible for 90% of people. So 90% recidivism rate in the treatment of obesity. And some people, and I like to use the term set point for this defense of body weight, and again, 90% of people who go on a diet are going to regain that weight within 2 years. So, what are the factors that predispose us to become obese and affect our ability to lose weight? Well, perinatal environment, again, I want to stress that this is probably the most important thing we can do, is identify the factors that contribute to making a child obese, because that's what they're going to be when they're an adult. The psychosocial environment, exercise, drugs, and surgery. So, what can we do about obesity? And again, the best treatment is prevention. Because once you become obese, it becomes almost impossible for the majority of people, save for surgery, which does something magical that we don't understand, because those people are not hungry, even though they lose weight. Something about rewiring their gut changes their brain. The brain doesn't think it's starving anymore. There's a huge push now to try to understand it, but we don't. But the best thing we can do is identify people at risk and try to prevent them from becoming obese. That's all I have to say. Questions? Yeah.
I'm wondering about what's the safety of dieting, presuming you take into account your micronutrient, protein requirements, carbohydrate requirements, but you fail, or you're going to regain. I saw on TV someone was talking about repeated cycles of dieting resulting in increased visceral fat, and that being so super bad. And I have failed my diet, so I would like to start again, but I'm a little worried.
Right. So this idea of yo-yo dieting has been around a long time. There's not good evidence that actually is true. There are studies pro and con on that. And the original idea was that each time you go down, you gain more weight when you come back up.
Yeah, and that's not happening to me.
There's not good evidence. There's not great evidence for that. The safety of dieting is that you should do it under medical supervision so that you make sure you get the right micronutrients and vitamins and calcium and minerals and so forth. and you don't do it to excess. If diets that try to have massive amount of weight loss, which is what most people want, are the ones that people fall off of. I mean, it really, and again, this look-ahead study that I showed you, the behavioral intervention, it's not dramatic, but you have to change your whole life.
I know.
If you intend to keep your weight off for a long term. You can't think in the short term, which is what most people who are obese do. You have to think over the long run.
And what about, sorry,
no,
metabolic syndrome and exercise? Because I find, you know, for me, exercise, aerobic exercise is fine. If I have enough calories, if I don't have to restrict calories, exercising is no big deal.
Right.
Get on my stationary bike in my underwear, do my 30 minutes, throw myself in the shower, and I'm good. But will it help with being, I'm overweight, so will the exercise help with the metabolic syndrome, with the increased risk of cardiovascular?
Yes, those are some of the things I talked about. So yes, it improves your cardiovascular fitness. It improves, so your muscle, by building muscle mass, you improve insulin resistance, or you become more sensitive to insulin. So the type 2 diabetes can be ameliorated by it. And again, there's a fair amount of exercise needed to do some of these things. It improves your blood lipids. So everything about exercise is good as long as you don't injure yourself. So you have to find an exercise, type of exercise that is not going to injure you. How much you do, there's, I don't know if you've been following it in the Times, Gretchen Reynolds has been writing these articles. There's a study out now that says that 1 minute of intense exercise, 20 seconds and then 3 or 4 minutes off and then 20 seconds is sufficient to give you the same cardiovascular fitness as somebody who's doing moderate exercise. I don't know. And they didn't look at some of these other endpoints, which are important. There's no question. So it's a zero-sum game. If you eat 2,000 calories and you exercise and get rid of 500 calories, you're going to be at a caloric deficit if your requirement is 2,000 calories a day. So you're going to lose weight. The problem is you get hungry when you exercise. And that's why exercise usually doesn't work very well by itself in a weight loss program.
I have found that if I'm not counting my calories, I just get increasingly hungry.
Right. And that's the presumptive reason why people don't lose weight who exercise. Yeah.
Yeah, the calories in, calories out model is interesting to me, as well as the a calorie is a calorie. Because just from personal experience, eating 2,000 calories of fruits or vegetables feels different, and the body responds differently just from personal experience than eating 2,000 calories of chips and candy bars. So I'm wondering that with we have the highest amount of our diet craze, and also the highest percentage of the population is obese at the same time. I'm wondering why we're focusing so much on weight loss drugs and not looking at subsidizing healthy food for people who can't afford vegetables or different things like that.
So it's being done in places. The problem is that people don't like to eat healthy foods. They have to learn how to cook them. They have to have the time to cook them. So, where's the highest rate of obesity in the New York metropolitan area? It's mostly in the lower socioeconomic areas. The kids are locked in their apartments because if they go outside, they're going to get shot. And so they get no exercise. The parents, often a single parent, is working 2 jobs often, so they're not home much. They get home, they don't have time to cook those healthy foods. So it's much easier. And the bad food, McDonald's and all that, they're cheap. That's how you can get a lot of calories for very little money. It's terrible quality. Now, you start out by talking about feeling different. That's a whole other issue. That has nothing to do with weight loss. It's a very real thing, by the way, because there are areas in the brain that are sensitive to the amount of glucose in your blood. This is something I've been studying for years, actually. And there are specific neurons that respond to how much glucose there is, or how many fatty acid, or how much fatty acid there is. And those areas are connected in some ways to areas that are involved in emotions, in your intellectual capacity. So food can definitely change your mood and change a lot of things about you. So you may feel different, but that's not, and that doesn't have, well, it has something to do with your energy homeostasis. But that's a whole different issue. Did that answer your question?
Yeah.
Okay. You look like you're not convinced though.
No, it's fine.
I gotta convince you. Yeah.
Is there any truth to that certain foods, when you eat them, like let's say 100 calories worth of carrots takes more energy to digest than 100 calories worth of sugar?
There's some, yes, but the amount that it takes to digest and assimilate is trivial compared to the 100 calories. There may be a small difference, but that's why, on balance, when you eat a regular meal and a regular diet, it's just not good evidence that. So complex polysaccharides, for example, that require more energy to digest them and break them down. Not a lot. Most of that's enzymatic. It doesn't cost a lot of energy. So it's that amount is fairly small compared to the amount that you're taking in. Yes?
Is there any good science that comes at this issue from a psychological point of view, like if you lower stress or if you meditate, you can maybe cause brain changes that will lower your hunger?
Well, so stress is a good one to talk about because the stress hormones, particularly cortisol in humans, increase deposition of fat, particularly the bad fat. I didn't talk about good and bad fat, but visceral fat, the fat that's in your belly, that the blood from that fat goes into your liver, which is the worst place for it to go, and that's one of the causes of insulin resistance. So cortisol ends up, when it's there, it's elevated in chronically stressed people. So it increases the amount of deposition of fat in adipose stores. So you may not put on more fat overall, but you're putting it in the worst possible place when you do that. Meditation, again, I'm sure there are dozens of studies. I just don't know the answer to that. Again, you've got to be able to overcome this hunger drive. If you're overweight and you want to lose weight, you're going to eat fewer calories than you need. Your brain is screaming at you that it's starving. Whether meditation can overcome that, I don't know.
But what I'm wondering is that on a long-term course of lowering stress or meditating, maybe you can actually change the wiring of the brain. So that it won't scream at you as much.
Yeah, so stress, there have been studies on stress, long-term stress relief, and most of these behavioral studies don't work particularly well. Again, not my area of expertise, so I don't want to be very dogmatic about that. But most behavioral studies, and psychologists have been involved with weight loss, and that's actually, Rena Wing is a psychologist. She's the one who did the look-ahead study, and some of this is psychological kinds of stress relief, and so that's part of this lifestyle change. So it is important. I just don't know about meditation. Yes?
I was curious now, I've seen a lot of work similar to what you presented, where it's always comparing one diet against another. Right. Are there any studies that sort of are rapidly changing diets in people? So approved diets that make sense from a nutritional point of view, but rather than letting your body, your brain get bored, get sort of homeostatic about what you're putting into your body, constantly changing it up and seeing the effect.
Yeah, I don't know of any such studies. My feeling is that these are often extreme diets. Now, things like the Mediterranean diet are pretty easy diets to eat, and people can stay on those. The Atkins diet, people lose a lot of weight on the Atkins diet. It's pretty effective. The problem is nobody can stay on it because it's boring, and there's just so much steak and red meat that you can eat. And you'd think that that'd be wonderful, but everybody I know who's been on that diet just can't stay on it for very long. Of course, that's not, some people stay on it for years. So the best advice is usually to slightly reduce your caloric intake, eat a well-balanced diet, don't eat junk food, you know, just keep a sensible diet that's not on the extreme in any direction. And that doesn't have to be boring, because you can continually, it's not that hard to eat healthy food if you have time and money, right? That's a big factor. And for large portions of our population, that's just not possible. And that's a real problem. You know, school lunch programs are one of the ways you get at this, but the kids go home and their mothers are going to feed them junk food because they, you know, if they're in a lower socioeconomic situation, because they don't have time or money to do otherwise. So that's the lower socioeconomic populations are at the biggest disadvantage, and they have the highest rates of obesity in this country and in other countries as well.
What do you consider slight caloric restriction?
Well, you really don't have to. So don't eat that bag of potato chips, right?
That's only 140 calories. That's not
right. But if you have a caloric deficit of 200 calories a day, right? There's a lot of slop in this set point, this thing that drives you back very accurately to where you were after you've dieted down. But there's slop in that. It's like the thermostat in your house. You know, it's not exactly 68 degrees when you sit at 68. And there's some evidence that you may be able to sort of sneak under that limit by dropping your caloric intake by just a little bit each day. The problem is there comes a point at which the system is going to revolt after you've lost this rate.
Oh, that's interesting.
But and that's never been tested because it takes a long time.
Yeah,
but it's a lifetime. It's a lifetime. That's what I mean about changing lifestyle. This has to be something you're committed to over the long run. You're not going to see immediate changes. And you know, you can also cheat, and you should cheat. This is part of the thing about things being boring. You should gain a little weight on the holidays. You know? The other thing that people don't know is that when you eat a lot, you don't see the increase in weight for 3 to 7 days. And it's not clear why that is. I mean, you'll eat a big meal and you get on the scale and you weigh a lot more because it's mostly water that you've accumulated with it. But if you have to continuously overeat for about 3 days before you start putting on enough excess fat. And at that point, most people in this room who are at pretty stable body weight, their system kicks in and tells them to lay off. And without thinking about it, most people, I'm not one of them, but an awful lot of people don't think about what they eat. I mean, I'm a previous chubby guy when I was a kid, and I lost weight when I was in residency. Well, actually, I gained a lot of weight in residency, and afterward I lost a lot of weight. But it was 10 years before I stopped thinking about food continuously. Right? But something has rewired my brain, but it took me 10 years before I had I still have to think about every calorie I eat. So if I overeat one day, I'm going to voluntarily, cognitively eat less the next day.
It's an interesting point you're raising, because you said a lot of people want to lose a lot of weight quicker.
Right.
That's how I was.
Right.
And I was interested to learn that Weight Watchers is going to the model of half a pound a week. That's not, to me, that's 250 calories.
It's a very sensible way to lose weight. The question is how many people can do that.
Can do it.
Have a strength of character to stick with. Yes?
There was an article in New York Times recently about fasting, and it seemed to suggest that you could eat more or less regularly one day, fast the next, and then so you see maybe 3 out of 5, 7 days you eat less, and then the other 4 you eat more regularly, or you waited till late in the day to eat. So there's this one person who would eat after 3 and 6 hours spell and then stop. So
yeah, the problem is that I think that's one study. It's an interesting concept. I'm not sure I understand the principle behind it. There are certain things so everybody knows you're supposed to eat a good breakfast. I'm gonna get back to your issue, but in fact, it doesn't matter. So how you separate your calories over the day probably doesn't matter a lot, except if you eat late at night, because when you go to sleep, your metabolic rate goes down. So the worst thing you can do is to eat late at night and assimilate all those calories, and then also have a low metabolic rate. Now, theoretically, it will come back and, later in the day. But I don't honestly know the answer to whether or not that's going to have a long-term application to weight loss. And I'm not sure I understand why that would work physiologically.
I think the theory, isn't it, that you're kind of tricking your body so that if you do have caloric restriction, these systems are going to kick in and your metabolic rate is going to lower. But if you fool your body by eating normally and then suddenly don't eat for a day and then go back to eating normally, that you're somehow fooling that system.
Remember I showed you that 24-hour fasting animal?
Yeah.
The brain? I mean, it doesn't take long for that. I mean, you can't trick your brain. It's pretty smart. And there are only a few things the brain has to do to keep us alive. You have to have a sex drive. You have to eat. You have to breathe. Right? I mean, other than that, sleep is probably good too. But and so eating, you have to eat. And there are many more systems in the brain that drive you to eat than there are to stop you from eating. Right? So, and that makes a lot of sense. So I just don't believe that you can trick the brain that way. Now, that's what I believe. That doesn't mean that it wouldn't happen.
I mean, I know you mentioned willpower, but I mean, it's easier to stop eating for one day than to go through a reduced calorie meal regime indefinitely. For
some people, I know people who've done that, who go on intermittent fasts, and some people can do that. For a lot of people, it's torture. I mean, there are religious holidays in both the Muslim world and Judaism, where there are fasts and caloric restriction, or for Ramadan, you don't eat for most of the day, and then you eat one meal a day. For the Jewish religion, you have Yom Kippur, where you fast for an entire day. People can do that, but doing it on a regular basis, you're talking about a lifetime change, by the way, right? I mean, you have to do this. Whatever it is you're proposing, you have to do it. Now, the other thing about fasting or caloric restriction is that it appears that you live longer. That systems in the body are designed in such a way that really not understood. So there's a guy named I forget his first name, Madison, who is in National Institute of Aging, and I've sort of known of him for years, and I see him at these meetings. And this guy exercises like a fiend, and I think he got his caloric intake down about 85% of what is normal requirement. He looks like a dead man walking. I mean, he's sallow, he looks horrible, but he seems happy, and he thinks he's going to live longer. It's going to be a real disappointment if he drops dead.
I thought that when they tried that in primates, it didn't
work in primates, but that was one study. And those are, and probably not going to be repeated because primate research is so difficult and now controversial. But yeah, it didn't work in primates.
Intensive exercise doesn't work in humans.
What's that?
Intensive exercise doesn't prolong life in humans either.
No.
Yeah.
Right, exactly. Well, and there's such a thing as being too thin. So the survival curve is actually an inverted U-shaped curve. So people have been very low in the below 20, BMI of 20, they start to have a lower life expectancy than people at the sort of normal range. And we don't really understand that. But that's part of this issue. Those are old data. And that's part of this issue about extending life expectancy by getting yourself down into that range. Anybody else?
Okay.
Oh,
yeah. Is there like a time, you're talking about that set point, is there a time frame where it's more changeable? Like say if somebody is able to adjust, like when they're in college, or like for children who are obese, if there's intervention in you, then does it not come back as often later on?
So we don't really know the answer to that in humans. A lot of the work that I've done over the years has looked at exactly that issue. mostly in the perinatal period. Problem is, I use rats to study, and the brain development in rats is very different from the brain development. I mean, not only the brain's completely different, very different, but developmental patterns and the development of the hypothalamus is completely different. So we can make permanent changes in the propensity of an animal. So we breed animals that are bred to become obese if you put them on a high-fat diet only, and then they'll stay lean otherwise. So they're genetically predisposed. But if we do certain things during the first couple of weeks of postnatal development, we can prevent that from happening. So we can take these bad genes and modify them early in development. And in fact, exercise, even after the hypothalamus is already developed, is a little window of time before puberty in rats where in these genetically predisposed animals, if we give them 2 weeks of exposure to a running wheel, and rats love to run and running, they run miles a day, it will prevent them from becoming obese later in life. Right? But the brain is still, some parts of the brain are still developing during that period. And that's the problem, is you got to, and that's why I keep going back to this prevention thing, and the prevention really has to be early on. Perinatal period, and we don't know a lot of the factors that predispose. We do know that obesity and gestational diabetes both predispose to obese offspring, and protein and caloric malnutrition, paradoxically, predispose, again, mostly animals, but there are a number of really interesting human studies and some natural experiments after World War II where there was a severe famine in the Netherlands and Germany, and China had a similar, not during World War II, but other time, where the offspring of mothers who were severely calorically restricted during that period of time, big increase in incidence in obesity and type 2 diabetes. So that period of time when organs and particularly the brain are developing, that's when we want to step in. The problem is we don't really know how to predict who's going to become obese, because you don't want to treat every kid that way. It's not appropriate. Right? You'd want to know who are the, well, you know, if they have one obese parent, the likelihood of becoming obese is increased. If they've got 2 obese parents, those kids are really predisposed, both probably genetically and being in an obesogenic environment. Mm-hmm. We know that it's genetic. There's a genetic component because there have been studies where identical twins have been separated at birth and raised in separate families, and the concordance of obesity is, even in different situations, is about 70%. There have been at least 2 studies to show that. So that would be my take-home message, is we've got to concentrate on these early life events.
Okay, I think we're going to stop it there, but one more round of applause.